So I love playing video games, and it's something that I've passed on to my 8-year-old brother as well. And 9 times out of 10, I beat him fair and square. But not in Pong. In Pong, he manages to beat me every single time. I don't know what it is about Pong, but I just can't win. So, I did the only logical thing to do. I built a deep queue network that would play Pong for me, and it turns out there's a bunch of cool, fancy machine learning stuff that goes along with it. Ready to start? Let's go. Now, to make this, we need to understand deep learning and reinforcement learning. There's millions of resources online that'll help you with deep learning, so we'll leave that for now. But reinforcement learning is a little bit more complicated. For the sake of this video, we're just going to cover the basics, but if you want more detail, you can read my article. In reinforcement learning, you have agents, states, and rewards. So the agent is the one that can take actions to actually change the environment. The state is basically the state of the environment. So for example, in Pac-Man, it would be the image of the board. And the reward is how the agent can track if it's accomplishing its goal. So for example, in Pac-Man, you would get a score. Classic reinforcement learning, or Q learning, is essentially the brute force method, where the agent has every possible state and action, and each of them has a corresponding Q value. The highest Q value will dictate which action the agent will take in any possible scenario. This is known as the agent's policy. So it's kind of like a guidebook. It'll just look up what to do and then do that action. This guidebook is called the Q table, Q for quality, and it essentially contains all possible state action pairs. Basically, as the agent takes actions and gets rewards, based on those rewards, it'll update the values in its Q table. To do this, it uses this monstrous function. The way deep Q learning works is essentially by slapping a neural network, a very good function approximator, as a function approximator for the Q function. The fundamental problem in Q learning is that the agent can only take good actions in situations it has seen before many times. This is a very big problem, especially once you start dealing with much more complex environments like Pong.
So that's it, right? We just slap a neural network onto there and get going, right?
Nope, not quite. It's actually much more difficult than it seems because neural networks have a lot of things that need to be considered. Reinforcement learning and deep learning don't play well together for several reasons. In classic deep learning, the data is not correlated and has a static distribution, whereas in reinforcement learning, the data is highly correlated and has a dynamic data distribution. When I feed my regular neural network an image of a cat, and then I feed it an image of another cat, they're not related to each other. In RL, though, every state is highly correlated. If I'm walking to the right, I'm probably going to keep walking to the right, so all my observations will be me walking to the right. The agent might think, okay, so I'll just always walk right. And we don't want that to happen. We don't want any sets of data to be overemphasized in our training. So we don't want this to happen. Probably the most important thing in making these two work together is experience replay. What experience replay essentially is that instead of always training on the same experiences, we create a buffer memory, and we essentially collect a large amount of experiences there, and then we randomly sample from them. So that way, if I'm walking to the right, and then I walk to the left, and I walk to the right, then instead of taking just the most recent observation, it takes a random sampling of those, creating a static data distribution and decorrelating the data within time. There's a lot of other little things when it comes to implementing a DQN, but I think I'm going to leave them out of this video just for the sake of length. However, if you do want to know about them, you can check out my article on Medium. I'll post a link in the description. Now I think we should see some Pong. Thank you so much for watching.